Dinosaurs. The very word evokes images of colossal creatures, their massive frames casting long shadows across prehistoric landscapes. From childhood drawings to blockbuster films, dinosaurs have captivated our imaginations for generations. Their immense size is a source of endless fascination, a window into a time when giants ruled the earth. We marvel at the thought of these creatures so much larger than ourselves roaming the planet millions of years ago. Their size is a testament to the power of nature, a reminder of the incredible diversity of life that has existed on Earth. But how big were dinosaurs really? How did they grow to such colossal sizes? And what can their size tell us about their lives and the world they inhabited? The study of dinosaurs is a journey into a world long gone, a world we can only begin to imagine. By piecing together the clues left behind in the fossil record, we can begin to understand these magnificent creatures and the age in which they lived. Their size, one of their most defining characteristics, holds the key to unlocking many secrets about their lives and the evolution of life on Earth. Size is more than just a number in the animal kingdom. It's a fundamental trait that profoundly influences an organism's biology, behavior, and interactions with its environment. For dinosaurs, size was a crucial factor in their evolutionary success, shaping their ecological roles and interactions with their surroundings. Larger animals, for example, have different physiological needs and constraints compared to smaller ones. They require more food and water to sustain their massive bodies, influencing their foraging strategies and habitats. Their sheer size also plays a role in predator-prey relationships, with larger predators often occupying the top of the food chain, shaping the dynamics of their ecosystems. However, pop culture often exaggerates the size of dinosaurs, portraying them as uniformly gigantic. While it's true that many dinosaurs reached impressive sizes, it's essential to remember that not all dinosaurs were titans. The dinosaur world was incredibly diverse, with species ranging from the size of a chicken to the length of a Boeing 737. Understanding this diversity in size is crucial to accurately reconstructing the Mesozoic world. Paleontologists, the detectives of the prehistoric world, use fossil evidence to estimate the size of dinosaurs. This is no easy feat. Imagine trying to assemble a puzzle with only a handful of pieces. That's often the challenge paleontologists face when trying to determine the size of a dinosaur from incomplete skeletons. They use a variety of techniques, including comparing the size and shape of fossilized bones to those of similar living animals. By extrapolating from these known measurements, they can estimate the size of the missing parts of the dinosaur's skeleton and ultimately its overall size. However, this process is not without its limitations. The fossil record is inherently incomplete. Finding complete skeletons of dinosaurs is incredibly rare. Most of the time, paleontologists have to work with fragments, making accurate size estimation a scientific jigsaw puzzle. Additionally, fossilization itself can distort bone size, adding another layer of complexity to the task. Despite these challenges, paleontologists have developed increasingly sophisticated methods for estimating dinosaur size, refining our understanding of these ancient giants. The largest dinosaurs were true behemoths, pushing the limits of size in terrestrial animals. Among these titans were the long-necked sauropods, such as Argentinosaurus, Brachiosaurus, and Diplodocus. These herbivores were the largest animals to ever walk the earth, some reaching lengths of over 100 feet and weighing as much as several elephants combined. Their massive size was likely a form of defense against predators, and allowed them to reach high into the treetops for food. But the carnivores were no slouches either. Tyrannosaurus rex, with its massive skull and bone-crushing teeth, still reigns as a pop culture icon. However, Spinosaurus, with its crocodile-like snout and potential for semi-aquatic life, might have rivaled or even surpassed T-Rex in size. The skies, too, were home to giants. Pterosaurs like Quetzalcoatlus, with wingspans exceeding 30 feet, soared through the Mesozoic skies. These flying reptiles, while not dinosaurs themselves, were an integral part of the dinosaur-era ecosystem, and showcased the impressive scale of reptilian life during that time. Not to be outdone, the oceans were also teeming with massive reptiles. Ichthyosaurs, with their streamlined bodies and powerful tails, resembled dolphins and hunted prey in the water. Some, like Shonosaurus, grew over 50 feet long, making them giants of the seas. These examples highlight the incredible diversity and scale of reptilian life during the Mesozoic era, a time when giants ruled the land, air, and sea. While it's easy to get caught up in the awe-inspiring size of the largest dinosaurs, it's important to remember that not all dinosaurs were colossal. In fact, many dinosaurs were quite small, some no bigger than a chicken. These smaller dinosaurs played important roles in their ecosystems, often occupying niches that their larger counterparts couldn't. Compsognathus, for example, was a tiny predator, about the size of a turkey, that likely hunted insects and small animals. Microraptor, a feathered dinosaur with 4 wings, was even smaller, about the size of a crow, and likely glided between trees in prehistoric forests. These smaller dinosaurs highlight the incredible diversity of the dinosaur kingdom. Their small size offered them advantages in terms of agility, maneuverability, and the ability to exploit different food sources. They were just as successful in their own right as their larger relatives, demonstrating that size isn't everything in the struggle for survival. Section 6. A human yardstick, grasping the scale of dinosaurs. Numbers on a page can sometimes fail to capture the true scale of these prehistoric giants. To truly appreciate their size, we need a point of reference, something we can relate to, ourselves. Imagine standing next to a Brachiosaurus, its shoulder towering over a 4-story building, its neck stretching higher than a telephone pole. Or picture yourself face to face with a Tyrannosaurus rex, its head alone larger than a car, its teeth the size of bananas. Even smaller dinosaurs like the dog-sized Velociraptor would have been formidable creatures, their agility and sharp claws making them swift and deadly hunters. These comparisons highlight the incredible scale of dinosaurs and their place in Earth's history. They were not simply large animals, they were giants that dwarfed anything alive today, reminding us of the incredible diversity and power of life throughout our planet's history. Section 7. The Why of Size, Evolutionary Advantages and Environmental Pressures. The question of why some dinosaurs grew to such colossal sizes has intrigued scientists for decades. A confluence of factors likely contributed to their gigantism. One key factor was the abundance of resources available during the Mesozoic era. The climate was generally warmer than today, and plant life flourished, providing ample food for herbivorous dinosaurs. This abundance of food, combined with a lack of competition from mammals, which were relatively small at the time, allowed dinosaurs to thrive and evolve to larger sizes. Their unique physiology, including a bird-like respiratory system that allowed for efficient oxygen intake, also played a role in their ability to grow to such massive proportions. However, size wasn't without its drawbacks. Larger animals require more food and water, making them vulnerable to environmental changes. Their size also made them less agile and potentially slower, which could have been a disadvantage in certain situations. The extinction of many large dinosaur species at the end of the Cretaceous period suggests that their size, while advantageous in many ways, may have ultimately contributed to their demise when faced with catastrophic environmental change. Section 8. The biggest of them all, a paleontological debate. The title of largest dinosaur ever is a coveted one, often sparking debate and intrigue among paleontologists. While Argentinosaurus, with its estimated length of over 100 feet and weight exceeding 70 tons, is often considered a top contender, other contenders continue to emerge from fossil discoveries. Patagodoton, another massive sauropod from Argentina, is a recent contender, with some estimates placing it as potentially larger than Argentinosaurus. However, the fragmentary nature of its fossil remains makes definitive size comparisons challenging. This ongoing debate highlights the dynamic nature of paleontological research. New discoveries constantly refine our understanding of these ancient creatures, and the quest to find the largest dinosaur ever remains a tantalizing pursuit for scientists and enthusiasts alike. Section 9. A Tapestry of Sizes, Celebrating Dinosaur Diversity and Adaptation. The world of dinosaurs was a tapestry of sizes, from diminutive creatures no bigger than birds, to colossal behemoths that shook the ground with each step. Their size, a product of millions of years of evolution, is a testament to their incredible adaptability and success in a variety of ecological niches. Their story is a reminder that size is but one aspect of an organism's evolutionary journey. From the giants to the dwarfs, each dinosaur species played a unique role in the intricate web of life that existed during their reign. As we continue to unearth their remains, we gain a deeper appreciation for the incredible diversity and wonder of the dinosaur kingdom, a world where size truly mattered, but never defined the limits of evolution's creativity.